All right. So last week we have seen what is a dimension. So dimension is a technique that we use to derive a physical quantity so that it can be expressed in terms of a combinations of a basic quantity. So first thing, before you derive the unit, especially in terms of a SI unit, what we want to know is the equations. So for a velocity, the equation is a change of displacement over time. So it is equals to del S over del T. That is if we want to do a simple calculations. So in calculations, what you have to do, you just calculate the change in the displacement, divide by the change in time in terms of value. But when it comes to dimensions, okay, when it comes to derivations of a unit, what are you going to do? You're going to put a square bracket here to tell the reader that now what are you going to do is to derive the unit, okay, but not to calculate its magnitude. So magnitude, you don't put a square bracket, but when it comes to unit dimensions, you put a square bracket to tell the reader now what are you going to do is not to calculate the values, but it is to derive the unit. So as you can see here, I put a square bracket beside the velocity. So square bracket for change of a displacement, and then a square bracket for change of time. All right, so now that I'm ready, I want to do derivations. So next, I'm just going to put in the symbol. So change of displacement symbol is del S, change of time is del T. Okay. So after that, what am I going to do? Now try to think. In the dimensions, we have, how many unit, how many quantity, basic quantity. So we have seen 7, I think. So we have seen the 7 basic quantity last week. So we have mass, length, time, electric current, temperature, amounts of substance, and the luminous intensity. Most of the time, we use the first 3. Okay, most of the time we use our first 3 in the first few chapter because it involves motion. So you try to think, now change of displacement, it belongs to which types of quantity? You're talking about displacement, which is length. Therefore, I use L here. So length over, now change of time obviously is time. So length over time. So L over T, which is equals to LT negative 1. Then from here, you refer to the table again. Look at what is the unit for each of these basic quantity. Now L, the unit is a meter. Okay, L, the unit is meter. Times the unit is a second. Therefore, the SI unit for velocity is ms negative 2. So when it comes to volume, okay, volume, we have a length times 3. Okay, because volume is equals to length times width times height. So length times width times height, all 3 of them, they are talking about length. Therefore, when it comes to dimensions, we use L times L times L. So you have L3. So again, length, the SI unit is in terms of meter. Therefore, we have meter cube. Okay, therefore we have meter cube. And next, accelerations. So acceleration is a change in velocity over the change of time. Okay, over the change of time. So when it comes to dimensional analysis, when it comes to derivations of unit, you use del V over del T. Okay, you put a square bracket. Now, sometimes you have to derive the unit for del V first. So you have to go back to the first step. Okay, you derive the dimension for velocity first. So once you have it, LT negative 1, you can then substitute it into the equations here. Okay, you can sub it into the equations for acceleration. So sometimes it involves more than one step. You have to do it twice or maybe even 3 times because you don't have the derived unit for some of the quantity in our equation. So in this case, we don't have derived unit for velocity. So you have to do a derivation for velocity first. Then you put it into acceleration. So now you have acceleration LT negative 1 over time. Therefore, the final unit is LT negative 2. So when it comes to SI unit, you have MS negative 2. Okay, MS negative 2. So this one we call unit in terms of base quantity. Okay, SI unit in terms of base quantity. Sometimes we have a special SI unit. Okay, for example, force. Special SI unit is Newton. But if the question is asking for base SI unit, then what you have to do, step by step, like the one that we just discussed. Okay, you have to start from its equation and then try to find out what is the SI unit for every single quantity in the equation. So now I'm going to give you the equation. I want you to spend 5 minutes to derive the SI unit for me. So density, the equation is mass over volume. Okay, mass over volume, m over v. So momentum unit is mv, m times velocity. So these two v, they are different v. In density, this capital letter V is volume. In momentum, this small letter v is velocity. Force, the unit is ma. The formula is ma. And then the work, in this case, we are going to use Fs. All right, and then for power, there are a few equations, but here let's try W over T. Okay, let's continue from a previous one. So now I give you these 5 equations already. What I want you to do now, I want you to spend 5 minutes to derive the SI unit for me. Don't give me special SI unit. I don't want Newton. I don't want a Joule. I don't want Watt. Okay, all these 3, even though they are SI unit, but they are known as special SI unit. What I want now is a base SI unit. Okay, base SI unit, which you are going to express it in terms of a meter, second, and kg. Okay, meter, second, kg. All right, so I give you 5 minutes from now to try these 5 questions. Okay, so if you are done, you may write down your answer in a message. Okay, in a message. So the answer for all five questions before we start to discuss. Gram and cm, they are not SI unit though. You need to remember what is SI unit. Well, in terms of unit, it is correct. But now the question is asking for SI unit. Okay, the answer for all five. Okay, not just one. Try to write out the answer for all five of them. See whether you got the correct answer or not when we discuss. Okay, I just want to make sure you tried it because this is a very common sense questions in the exam, especially in your UPS. Okay, they like to ask you to derive the unit. Oh, good. You guys can copy what Akram's did in the chat. All right. So straight away, you put the answer for all five questions. Density, momentum, force, work, and power, and then give me the unit. So far you can see quite a lot of a different answer in the chat. So who got the correct one? Aha. Okay, how about the rest, faster? So now let us try to see what is the correct answer. Okay, and see whether you write it down in the correct way, the way you write down. So density, we have the equations D equals to mv. So density, now we have a, let's see, with the right density equals to, so equation is m over v, but now I want to do dimensional analysis, derivation, so I put a square bracket here. So square bracket equations, m over v. All right. So m is in terms of a mass. So what is the symbol? So when it comes to mass, symbol is capital letter M. So capital letter M, we're going to put it here and then over. Now, volume, according to a previous question, we have L3. So over L3. Therefore, in terms of dimension, it is ML negative 3. All right. But the question wants the SI unit. Therefore, you have to change ML negative 3 into SI unit. So M is in terms of mass, SI unit is kg. L is in terms of length, so SI unit is meter. And the time is in terms of is T. Time in terms of T, so it's a second. So ML negative 3, M is kg, so I'm going to write down kg here. And then L is meter. So kgm negative 3, that is the SI unit. Okay, SI unit for density. Now, if the question is not asking for SI unit, of course, you can put G and a cm in the equation. All right. But when it comes to a derivation, most of the time, question will ask you to write down the unit. And this type of question can also come out in your final exam. I think this is one of the past year question, if I'm not mistaken, density. Okay, question asks you to show the dimension. So if the question asks you to show the dimension, mean it wants the ML negative 3. And then the questions, a sub-question, the second sub-question is asking for the unit. So unit is kgm negative 3. So these two things, 1 mark, 1 mark. So altogether, this question, just a derivation question, it worth 2 marks in your final exam. All right, so momentum. Momentum, symbol for momentum is P. So I'm going to put P here equals to square bracket M square bracket V. So mass, again, I have capital letter M, and then velocity in the previous questions, we have LT negative 1. So this is the dimension for momentum. Now I'm going to change this dimension into a unit. So again, M is kg, and then L is meter. So M, and then capital letter T is a S. So S negative 1. So kgm S negative 1. So dimensions we have already. SI unit we have it already. Force equals to MA. Okay, so force is a very special quantity where sometimes when the question is asking for just a unit, then you can give Newton. So Newton is what we call special SI unit. It is also SI unit. Now, what does it mean by SI unit? So SI unit is being used in international. Okay, so it doesn't matter which country are you from. As long as you're using this unit, this set of unit, then the scientists, they know, okay, what is a quantity? How do you calculate it? Sometimes there are some units that we use that are not belongs to SI unit. For example, the length of the palm. So that is the measuring apparatus that we use in maybe 50 or 60 years ago when we still don't know what is a meter, what is a cm. Okay, so in some places, some rural area, they use the length of the palm, the length of the arms at once of the measuring quantity. So all those, they are not SI unit. Okay, so when you use SI units, that means that you can, all the other countries, they know how you calculate all this quantity. So Newton is also known as a SI unit, just that it is not in terms of base quantity. Okay, now in exam question, they lie to us SI unit in terms of a base quantity, okay, in the base SI unit. So you need to do a dimensional analysis. You need to use the derivations method in order to find out what is the base SI unit. So force, okay, so we have a square bracket F equals to square bracket M square bracket A. So it is equals to M, and then A we have just now is LT negative 2. So the unit is kg ms negative 2. Okay, kg ms negative 2. So for work, so square bracket again, W equals to square bracket F square bracket S, which is equals to, now force from previous questions, we have MLT negative 2. Now when it comes to S, what is S? So S is a displacement. Okay, S here is not a second, but it refers to displacement. So displacement is a type of length. You measure with length. The unit is in terms of length. So you're going to have times L here. Okay, times L. So it is equals to ml squared t negative 2. So now you're going to convert it into SI unit. So m is kg, L is meter, but now the meter come with a square, so m squared, and then S negative 2. So this is a base SI unit for work. So now it's power. Power is square bracket P equals to square bracket W over square bracket time. Okay, square bracket W over square bracket time. So equals to, so from previous questions we have work done is ml square t negative 2. So divide by time, which is another t. Therefore, we have ml square t negative 3. Okay, because negative 2 divided by t, okay, t negative 2 divided by t means it's t negative 2 minus 1. So it is t negative 3, right? So t over 2 over t equals to. So the final unit is kg m square s negative 3. Okay, kg m square s negative 3. So now I give you 2 minutes to write down the correct answer, okay, for those of you who got the wrong answer. Before we proceed to the next function of the dimensional analysis, how are we going to use to prove something, whether it's correct or wrong? Okay, so 2 minutes for you to write down the correct answer for those who got the wrong answer just now. All right. So let's proceed to the next part. So if you have any questions, you may ask. Yeah, don't keep it in yourself. Okay, if you have any questions, you may ask. All right, now, other than we use it to derive the SI unit, we also use it to verify some things that we call the homogeneity of equations. Okay, so dimension analysis is used to check mathematical relation for the consistency of their dimension based on the principle of homogeneity. Now, what does it mean by homogeneity? Homogeneity states that all terms appearing on both sides of equation, they must have same dimension. Okay, so which mean the dimensions of the left hand side, okay, the dimensions, okay, wait, yeah. So dimensions on left hand side is equals to the dimension on the right hand side. Okay, so both sides, now you have an equation. For example, the equation is a plus b equals to c plus d. So you want to check whether this equation is valid or not. So you are going to check the dimensions on the left hand side and also the dimensions on the right hand side. Okay, you find out what is the final dimensions for this, the left hand side a plus b, and what is the dimensions for c plus d. Are they the same? If they are the same, means they might be correct. Okay, they might be correct. But if they are not the same, then we say they are not homogeneity. Not homogeneity means that this equation definitely is wrong. Okay, so it can check whether it is correct or wrong. Okay, it might be correct or wrong. Okay, based on whether their dimensions on the left hand side is equal to the dimensions on the left hand side or not. So the use of a dimensional analysis first is to determine whether a physical equation is correct or not, homogeneity or not, dimensionally. Now, I won't say it's correct or not. Okay, I would say whether it's wrong, because dimension. Now, keep in your mind that dimension can only check if an equation is wrong. It cannot tell you whether it is correct or not. All right, you might get the same dimension, but at the end, it's still wrong. Why? Because you don't know the constant value. You don't know whether the constant value used in the equation is correct or not. So I wouldn't say it's correct. Okay, to determine whether the physical equation is wrong. Okay, it's wrong. So it cannot check whether it's correct. All right, it cannot check it is correct or not. So to determine the unit of a physical quantity, so this one we just tried it. Okay, we can use it to determine the physical quantity, the unit of a physical quantity, and then to derive or construct a physical equation. So the last one, you just have to know its function is no longer in your syllabus. All right, last time we used to have a types of question where the questions give a situation, then you construct an equation based on the situation given, but it's no longer in your syllabus. So we are not going to look at the number 3 in our class. Okay, so number 2, we are done. So what are we going to do now is to look at the number 1 to determine whether an equation is wrong, right? You cannot tell whether it's correct, okay, but you can tell it is wrong if it is wrong. All right, keep in your mind. You can check whether it's wrong or not. All right. So dimension cannot be added or subtracted. Okay, what does it mean? Okay, we will find out soon. So the validity of an equation cannot be determined by dimensional analysis, but only obtained from a theory or can be determined by an experiment. Okay, so you cannot validate whether an equation is correct. All right, it will just tells you now they are dimensionally correct, but the equation is correct or not, you don't know. Okay, dimensionally correct, then yes, we can say it is correct. Okay, because if you mentions dimensional dimensionally correct or not, then the question is just want to check whether the dimension on left hand side is equal to the dimensions on the right hand side. Okay, so if it is the same, then you say it is dimensionally correct. Okay, dimensionally correct. But if the question asks you whether the equation is correct or not, you cannot answer that question. Okay, you cannot answer the questions. So dimension for dimensionless constant, for example, 1, 2, or 3, the value. Okay, then the dimension we straight away say it is equals to 1. Okay, any constant value, any values. If you have an equation, for example, I have a plus 2bc equals to c plus d. Then the dimension for 2, we are going to assume it is equals to 1. Okay, it is equals to 1. Why? Because it is a constant value and it don't have dimension. So if you put a value 1, then you can cancel it out in the equations. Okay, you can cancel it. So refractive index, no dimension, therefore it's equals to 1. Angle, no dimension, it is equals to 1. Ratio, okay, this is a very tricky question. So ratio of two quantity, okay, because you cancel out the quantity, so it is equals to 1. All right. So not just angle. Sometimes if you have a tangent theta, okay, it is also dimensionless. And then you have a cos theta, sine theta, they are all dimensionless. So the dimension is equals to 1. Okay, so tangent theta equals to a cos theta equals to a sine theta, and the dimension is equals to 1. And then another one most probably is a pi. So if you are given pi, then the dimension for pi is also equals to 1. Right? The dimensions for pi is also equals to 1. So yeah, I think that's some of the special case. So all these you have to know. Okay, it can be tested in your UPS. Okay, it can be tested in UPS. So ask you to choose which of the following quantity, okay, the dimension is equals to 1. Then maybe you're given some of the values, some ratio. Then all these situations, the dimension is equals to 1. Okay, the dimension is equals to 1. So when the dimension is not equals to 1, means that that quantity come with a unit. All right. So dimensional analysis is unable to determine if there's an incorrect coefficient. Okay, that's why I told you just now, you cannot say the equation is correct because you don't know whether the coefficient is correct or not. So missing term or extra term in any physical equations. Okay, so you can check the dimension is correct, but you don't know whether all these dimensionless constant is correct or not. So maybe you check, okay, a plus 2bc equals to cd. They have same dimension. But one thing that you don't know is whether this value 2 is correct or not in this equation. Why? Because it doesn't matter what value you put in the equation. You can put a plus 3bc equals to c plus d. A plus 4bc equals to c plus d. They are all going to have the same dimension. Okay? Because the dimensions for 2 is equals to dimensions for 3 is equals to dimensions for 4, which is equals to 1. So when you check the dimension, left-hand side is always equals to right-hand side. Okay, because the constant value 2, 3, and 4, it won't affect the dimension. Therefore, you cannot tell whether this equation is correct or not. Okay, you can only say they are dimensionally correct because left-hand side equals to right-hand side. Okay, so let's look at an example before we proceed to a question. Okay, before we proceed to the next part. So next part, you're going to check all these dimension. Okay, now you see the term here, dimensionally correct. Okay, dimensionally correct is whether left-hand side is equal to right-hand side or not. Okay, so this is what we check, left-hand side and right-hand side. So you cannot say equation is correct, but you can say it is dimensionally correct. The term dimension play a very important role in our conclusion. So without the term dimensionally correct, okay, if you just say the equation is correct, then you're going to get 0 mark in your final answer. Okay, now let's look at example. Okay, so now example. Given v equals to u plus 1 over 2at squared. Now you are given this equation. Okay, and then the question asks you to check if it is dimensionally homogeneous. Okay, dimensionally homogeneous. Now, a square bracket that I use in this example actually is well, I wouldn't say it's wrong, okay, because it depends on the books. The books that I refer to, they put a square bracket in a dimension rather than equation. But in your syllabus, they put the square bracket in equation. So we follow your syllabus. All right, you don't follow my example here. So what are we going to do now? The correct way in checking the dimension. okay, in your syllabus. Okay, you're going to do it separately. So left-hand side, we're going to start from left-hand side. So left-hand side, we have V. Okay, so the dimension for V, okay, we tried just now, which is equals to LT negative 1. All right, so you do it for left-hand side first. And then you do it for right-hand side. Okay, left-hand side, you're done. Now you do it for left-hand side. Left-hand side, we have U. U is also a type of a velocity. Therefore, okay, therefore, we are going to have the same quantity as a LT negative 1. So U plus 1 over 2, I forgot to put a square bracket. So 1 over 2 also need a square bracket. And then A and then T square. Everything in a square bracket, okay, in your syllabus. Okay, now what are we going to do next? Okay, we're going to write down the dimension for each of the term. So for U, okay, for U, the SI unit, the dimension for U is same as V. Therefore, we have LT negative 1 plus, okay, plus. And then the dimension for half, 1 over 2, okay, like I told you just now, is equals to 1. So you don't have to include in your calculation. Okay, straight away you can ignore it because it is equals to 1. And then A, we have LT negative 2. And then this T, okay, this T is a T square. So times T2, okay, times T2. So we have LT negative 1 plus LT negative 2 times T2. Now, what are you going to do next? Okay, you're just going to rewrite LT negative 1 first. Okay, LT negative 1 plus, so what are you going to do? You simplify AT square. You simplify this part. So negative 2 times a T square is equals to L. Okay, so this one and this one cancel out. So remaining term is L. Okay, now according to a rules just now, dimension cannot be added or subtracted. So means that this is the dimensions on the right hand side. You cannot simplify it anymore. Okay, you cannot simplify it anymore. So when you compare left hand side and right hand side, obviously they are not the same. Left hand side, what do you have? You have only this, LT negative 1. But right hand side is LT negative 1 plus L. So which means they are not equal. Okay, so in this case, what you can say, you can come into a conclusion, say that left hand side is not equals to right hand side. Okay, left hand side is not equals to right hand side. Therefore, we say they are dimensionally not homogeneous. Okay, dimensionally not homogeneous. So the conclusion is not homogeneous. So this question, usually it worth 3 marks in your exam, okay? The calculations that you show here, left-hand side and right-hand side, you need to show both. Then you obtain 1 mark. Conclusion, they are not equal, 1 mark. Not homogeneous, 1 mark. So usually this is a 3 marks question, okay? Usually. So you look at the notes in an example. Okay, here it says notes. Dimensions cancel just like algebraic quantities and numerical factor, like half in the equation. Okay, and it does not affect the dimensional check. So for a multiplication, okay, multiplication or division, you can do it like how you solve equations, how you do a numerical simplification. All right, but for addition and subtraction, you cannot do it. Okay, you cannot add it, you cannot subtract it. All right, so this one, if you look at the equation, the dimensions on the left does not match the one on the right. Okay, so therefore it is not homogeneous. Now, when it is not homogeneous, straight away we can say the equation is incorrect. Okay, the equation is incorrect. So that's why I can tell you, that's why I told you just now, you can use dimensional analysis to prove that an equation is wrong. Okay, so by checking the homogeneity. So if they are not homogeneous, then definitely the equation is wrong. Okay, if they are homogeneous, just mean they might be correct. Okay, you cannot come into the conclusion say that they are definitely correct. No, there's no such thing that they are definitely correct. All right. So they are not homogeneous means they are definitely wrong, but you cannot say they are 100% correct if they are homogeneous. All right, now example 6. Example 6, now you're given an equation S equals to ut minus 1 over 2at. Now you are given an equation. Question asks you to check whether they are dimensionally homogeneous. So what are you going to do? You are going to do the same things that like I showed you just now. Okay, you do for left hand side. So left hand side now what we have is S. Okay, so equation for S, which is displacement, is just equals to L. And then for right hand side now is slightly more complicated because now you have a U T minus 1 over 2 A T squared. Okay, so what are you going to do? You're going to simplify it. So U, I have LT negative 1 times with a T minus, now 1 over 2 again, I'm just going to cancel it out because it is equals to 1. Okay, so A, I have LT negative 2, now T squared is T2. All right, so when I simplified it, now when it comes to multiplication or subtraction, so this one I can simplify it, this one I can simplify it, okay, because they involve multiplication. So what am I going to get now is LT negative 1 times T, you're going to get L, okay, and then minus, now LT negative 2 times T squared, again you're going to get L. So L and L, you can simplify it, okay, they are not equal to 0. L and L means that at the end you are going to get L on the right hand side, okay, because they have same dimension, so you can do the simplification. So L minus L, the final dimension is L. So how do I know the final dimension is L? So try to imagine now if you have a 2 cm minus 1 cm. Okay, the dimension, the unit for the final answer, it's also in cm. So it shows that this is how we should do it. So 2 cm, cm is L, minus 1 cm, cm is also L. So the final unit is in L. Why? Because the unit is still in cm. Okay, so this is one of the example. So L minus L, the final dimension is L. Therefore, okay, what we have now, okay, right hand side is equals to left hand side. So LHS equals to RHS. So you must do them separately, okay? You must do it separately. You don't do it in a combined form, okay? You don't do it in combined way. So the examples that I give you here, because in university, they use this symbol, okay? You can see here, this one to shows that now you are unsure whether left hand side is equals to right hand side. But this symbol is not in your matriculation syllabus. So what are you going to do? You are going to do them separately. Okay, so kalau kamu tengok example saya, dia tulis sekaligus. Sebab apa? Sebab saya guna simbol ini. Simbol ini di university dia mewakili kamu tak pasti juga. Sama ada right hand side sama dengan left hand side. Okay, tapi kita tak pakai simbol ini dalam syllabus Anda. Jadi dalam syllabus Anda, apa yang Anda kena buat? Anda kena buat secara berasingan. Okay, Anda kira left hand side dulu, and then Anda kira right hand side. Baru Anda buat conclusion. Sama ke tak sama? Okay, so that is how you solve it. So addition and subtraction, they won't change the dimension. Okay, they won't change the dimension. It can only be done if both quantity, they have the same dimension. So if they have same dimension, you can simplify it like what I did. So L minus L equals to L. If they don't have same dimension, for example, like in a previous question, you have LT negative 1 plus L, so you cannot simplify it, therefore you leave it like this. Okay, you leave it like this. So the dimension on the left equals to the side, equals to the one on the right. Okay, on the left, they are now matching to the right. So the relationship, we can say they are dimensionally correct. Okay, dimensionally correct. But, okay, but what happened here is, now, this one, okay, this is what I told you, why it's important. Now, this example is why dimensional analysis can't tell whether an equation is correct or not. Because the correct equation actually is S equals to U plus 1 over 2AT squared. Okay, so you got dimension left hand side equals to right hand side, but in fact this equation is actually wrong. Why? Because the sign is incorrect. The correct sign is plus. Okay, but in the original equation they give you minus. So even though they are dimensionally correct, okay, but in terms of theory, in terms of our syllabus, they are wrong. Okay, this equation is actually incorrect. So dimensionally correct but incorrect equation. Okay, so the correct equation should be S equals to ut plus 1 over 2at squared. All right, so the reason why dimensional analysis cannot tell you whether it's correct or not, because first thing, you cannot check the sign. Okay, you cannot check whether the plus minus sign is correct or not. Okay, the plus and the minus sign is correct or not in an equation. The second thing, you cannot check whether the constant value is correct or not. Constant value, or we say dimensionless quantity. Okay, dimensionless quantity. So you cannot tell whether the half in the equation is correct or not. Okay, so sometimes maybe they just give you an equation S equals to ut minus 3at squared. You can still get dimensionally correct, but it is an incorrect equation. Right? So because of this reason, it cannot tell you the sign is correct or not. It cannot tell you whether the dimensionless quantity, especially the constant value, is correct or not. So you can only use it to check dimension. You cannot use it to prove that an equation is correct. All right, now let's go back to your handout. Okay, so the one that I showed you just now, this is actually my own notes, okay, where I use in my class. So now, because they want to standardize it, so we have to switch it back. We have to use your handout. Okay, so I'm going to switch between two notes. All right, because frankly speaking, I like my own notes more compared to your notes. Okay, now let's try exercise 1. Okay, let's try exercise 1. Determines whether the following expression are dimensionally correct. Okay, so now I want you to try it by yourself first. I give you 10 minutes. Okay, I give you 10 minutes to try all these questions. Okay, so you have three questions. Okay, I give you 10 minutes to try all these three questions. Okay, even though we have discussed it just now, I want you to try it as well. Okay, I want you to try it as well. So try these three questions in 10 minutes. I will show you the correct answer after this. Okay, so remember to split into left hand side and right hand side. Okay, you do it for the left hand side first and then redo it for the right hand side. All right. So I believe at least you have done with the first two questions. Question number 3 is a bit difficult because it involves a square root. Okay, so I'll show you how to do it after this. Now let's start from questions 8. Questions A, left hand side. Okay, left hand side. We're going to begin with a left hand side, which is a S. S is displacement. Okay, so displacement, the dimension is very simple, which is just an L. And then the right hand side, what do we have? Okay, we have a U, T. Okay, now you see you got the correct equations here with a plus sign, and then 1 over 2 A T squared. Okay, so this is how you should write it. So after that, what are you going to do? You're going to simplify it. Okay, you're going to simplify it, which is equals to, now U is a LT negative 1. Okay, to make it easier, I'm going to use a bracket here. So plus, okay, plus, now this 2 is a constant value without dimension. Therefore, it's just equals to 1. And then LT negative 2 and a T squared. Okay, simplify it, you got a L plus L, therefore it is equals to L. So therefore, okay, therefore your conclusion is left hand side equals to right hand side. Okay, and then answer the question. The equation, okay, the equation is dimensionally correct. Okay, so make sure to answer the questions. Every time you need to answer the question. So after you came to the conclusions, left hand side equals to right hand side, then you answer the question, say it is dimensionally correct, because the original question asks you to determine whether the following expressions, they are dimensionally correct or not. So you must answer the question. Okay, so this one we call answer the question. It worth 1 mark in your exam. Okay, now second questions. Second questions, you have a V equals to U minus 2GS. Now I'm going to show you the second methods that you can use to solve the question. Okay, so left hand side, again, we have a V where its dimension is LT negative 1. Right hand side. Now right hand side, sometimes students, they like to split it into 2. Okay, so you calculate the dimensions, you solve the dimensions for U first, and then you solve the dimensions for 2GS. Also can. So let's try the second method. Okay, so square bracket U, where the dimension is LT negative 1. Okay, and then we have the second part of the equation. So and then you do it for 2GS. So 2G S. So you do it separately. Okay, you do it separately, also can, nothing's wrong with it. So which is equals to, now 2, again, the dimension is 1. And then G, now G is also a type of acceleration. Therefore, the dimension is same as acceleration. So L, T negative 2. And then S is a length. So you have a L here. Okay, S is displacement, therefore you have an L. So what do we have as a final answer? It is equals to, now L times L is L squared, so T negative 2. Now if you do it in this way, you use second method to solve it. So what are you going to check is, you are going to check the dimension for all three quantity. So left hand side, we have this one. Right hand side, we have LT negative 1 and L squared T negative 2. Therefore, our conclusion is left hand side is not equals to right hand side. Okay. So now you can make a conclusion. So this equation. Okay, the equation is dimensionally incorrect. Okay, dimensionally incorrect. So first method, you just combine it. You just combine the right-hand side into 1. All right, you combine both of them into 1. Second method, you can split them. Okay, you can split it. So you calculate the dimension for U first, and then you do the dimension for 2GS. So both method, both method are correct. They are all being accepted in the exam. So it's up to you which one you want to use. Okay, which one you want to use. So now let's look at the questions number 3. So questions number 3, we have t equals to 2 pi square root L over G. So left-hand side, left-hand side we have t, where t is period. Okay, period means a time. So you have t. All right, the dimension is t. Now, how are we going to solve the one on the right-hand side then? So right-hand side, square bracket, you can put 2 pi because both of them, they are dimensionless quantity. Okay, means that they don't have unit. And then square bracket, square root L over G. Now, how are we going to simplify square root L over G? So it is actually equals to 2 pi. So L over G is actually L1 over 2 and then over G1 over 2. Okay, square root, the power is half. Okay, square root, the power is half. Therefore, you can rewrite it as 2 pi L1 over 2, now G negative 1 over 2 because it's denominator. Okay, because it's denominator. So next, again, this is 1, right? And then L 1 over 2, the unit, the quantity that we're going to have. L is length. Okay, length we have L, so the power is half. And then G again is a form of acceleration. Therefore, we have LT negative 2. Okay, and then the power is half. Okay, the power is half. All right, so we are going to simplify it now. Okay, we're going to simplify it now. So how are we going to simplify it? Let's see. So L, just now I forgot something anyway. L half, okay, L half is correct. And then yes, that's true, correct. So next, what are we going to do? Okay, so we have, okay, this one we cancel it out. So L1 over 2 times, now this one you're going to bring it in, okay, the power you're going to bring it in. So we have L negative 1 over 2 and then T. Now negative 2 times negative 1 over 2, it becomes 1. Okay, so it becomes T. So L half times L negative half, we should then give you just T. Okay, because L and L, they're going to cancel out with each other. Right, L and L cancel out because one positive, one negative. So L1 over 2 times L negative 1 over 2 is equals to L1 over 2 minus 1 over 2, which is L0, which then give you 1. Okay, so the final answer is T. So now what can we say? So left-hand side, we have T. Right-hand side, we also have T. Therefore, the conclusion is left-hand side equals to right-hand side. So this equation, okay, the equation is dimensionally correct. Okay, dimensionally correct. So this is how you solve questions number 3. So questions number 3 is slightly more complicated because of the square root here. Okay, so you have to know a bit of the law of indices because you need to know how to change a square root into a fraction, into a power, okay, into an index. And then you need to know what happens when you have a power that is equal to 0. So L with a power of 0 to the power of 0 is equals to 1. Okay, is equals to 1. All right, so that is the last questions. Okay, the last question. So far, any question?
No, madam.
Okay, so I hope you're still alive. Okay, because this one is slightly more complicated compared to just derivations of unit. Okay, derive unit. So make sure you understand how to solve it. All right. So if you understand, I think that marks the end of our class. Okay. So if you don't have any questions, then you may leave the class now. All right.
Thank you, madam.
Thank you, madam.
Thank you,
Thank you,
madam.
madam.
Thank you, madam. Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.